Welcome everyone. In this video lecture, we will solve a GATE 2013 question in which we have to find the small signal resistance calculation in a diode-based NMOS transistor. So here we can see that there is a NMOS transistor, okay, which is in the diode connected nature, okay, in which the gate in, this one is the gate in, and this one is the drain in is sorted, and this one is our source in. Okay, so what we have to do in this question, we have to find the small signal resistance, that is our dvb by, we have to find dvb by del id. We have to find this. Okay, so the other thing, and the other parameter, the vb value, that is our vdd or vb is 2 volt, and the transconductance parameter is kn 40 microampere per voltage square, and threshold voltage is given 1 volt, and we have to neglect the channel length modulation. So in this case, first we have to think the transistor in operating in which region. So we can say that the transistor, when gate and drain is sorted, the transistor is in the saturation region. Saturation region when gate and drain sorted. Okay, for the time being, suppose for the saturation region, the condition is VDS should be greater than equals to VGS minus VT. Okay, so from this one can say that the VD value is same as that of VG, because both having the same potential. VG equals to VD, so one can write VD minus VS is greater than equals to VG minus VS minus VT. Okay, so now here we can see that this VD and VG will be cancelled out. So this value minus VS will be always greater than minus Vs minus Vt. Is it okay or no? Very simple thing is there. Okay, I am highlighting this portion. The condition is VDS greater than equals to VGS minus VT for saturation. Okay, for this one, I want to make the IDVDS curve. Okay, so for this one, this point is nothing but simply VGS minus VT. So above this one, it should be in saturation region. Okay, and before VGS, it should be in linear region. Linear region. Okay, and this one is slightly tilted, so we can say channel length modulation is also there. So for the timing, we have to neglect. So if the condition when VDS is greater than equals to VGS minus VT, our transistor is in saturation region. So we can directly say that minus Vs will be always greater than minus Vs minus Vt. For example, if we say Vs is minus 5 volt, so we can say minus 5 is always greater than minus 5 minus 1. This one. So minus 5 is greater than equals to minus 6. Okay, this one is just as an example. I am taking Vs equals to minus 5. Okay, so this is the concept. So the device is in the saturation region, and this transistor works as a diode. So the only current in this one is id. Okay, so one can write the equation for the drain current equation in the saturation region. So mainly it is a very simple question, but we have to know a few concepts. So id equals to, as we know, the mu n cox w by l by 2 VGS minus VT whole square for saturation region. And in the question it is clear that no need to select the channel net modulation. So we are not writing 1 plus lambda VDS. Okay. So this one is a very simple. If we write this equation, now it is very easy. Okay. So after that, what we have to write? Okay. Once again, I am writing one more thing. ID equals to mu n cox w by L by 2 into now VGS. Okay. So VG minus Vs minus Vt whole square we can write. Okay, and in this question, our Vs is nothing but simply our grounded, so we can write 0, and Vg equals to Vd is nothing but simply Vb, so it should be 2 volt. Okay, so Vs will be 0, so now I am not putting the all value, I am just writing the equation first. One can simply write this as a Vg minus Vs. Okay, Vg minus Vs. So it should be nothing but simply Vg is Vb minus Vt whole square. Because this term Vs will be 0. So we can write and Vg is nothing but simply our Vb. Okay, so don't put this value right now. Why? Because we have to find dVb by del id. Okay, so what we have to do? After that, we have to differentiate id with respect to vb. It is very simple now. So it should be mu n cox by 2 into wl. Okay, now we have to differentiate. So 2 will be in coefficient, vb minus vt, and 2 minus 1. So 1. Simple differentiation. Okay, so we can write this one. Is it okay? Very simple equation. Means what I am writing, dy dx of x square is 2x. That concept. Okay. So now del I d by del vb. Okay. So first find this one, del id by del vb is given. So mu and cox w by L value is given, and this 2 and 2 will be cancelled, and this value mu and cox wl is given 40 micro. So one can write 40 into 10 to the power minus 6 into Vb minus Vt. Vb is given 2 volt, so I am writing 2 minus 1. So it should be 40 into 10 to the power minus 6. Okay, so now after that, we have to, in the question they are asking about the small signal resistance, so we have to just reverse. Del vb by del id is nothing but simply reciprocal of 1 by 40 into 10 to the power minus 6, or we can write, okay, for 10 to the power 6 will be in the denominator, so we can write like that. So 0 0 will be cancelled, so 25 kilo ohm. So the small signal resistance for this question is very simply we can write 25 kilo ohm. Okay, so this one is the answer. Okay, so actually I have forget to write the option. There is, in this question there are four options. Okay, the first option is say 12.5. Actually, we have to find in the kilo ohm, so 12.5, 25. C option is say 50, and D is say 100. So which should be the correct answer? So our correct answer will be, sorry, 25 kilo ohm, because in this question they are asking in terms of kilo ohm, so we have to write this as a kilo ohm. So this was a very simple question, but we have to know the concept, in which first we have to think this, what is del v, v by del id, the small signal resistance. Okay, so this transistor is operating in the saturation region and it acts as a diode. So for saturation region, how it is saturation? We have already derived. Means the VDS is greater than VGS minus VT. So it is in the saturation region. Okay. Then we have to write the simply write the what equation for the saturation region, drain current saturation equation. Okay, that you have to remember. It is very easy for electronics. So after that, we have to differentiate this one del ID by del VB by keeping VG equals to VB because VG is nothing but simply VB. Okay, so after that, again the main equation in terms of IDVBE as a function of ID as a function of VBE is this one. Now, after differentiating, what we will get? We will get the value of del ID by del V del VBE. So it should be 40 into. So now, if we make it reverse del VB by del ID, it should be this one. So the final answer will be 25 kilo ohm. So the answer will be 25 because in the question it is asking in kilo ohm. So this is all about this question. So thank you for watching.